So it's time to start our class and moving to third Roman 6. So one of all-time favorite important sum. So yesterday I told you regarding with these important sums. Now we are moving to third Roman question number 6. It was given many number of times in your intermediate examination. So moving to third Roman 6.
Sir, are these 7 marks questions, sir?
Yes, correct. Shilpita, it's 7 marks sum.
Okay, sir.
Right. So moving to third Roman 6. And it is one of all-time favorite 7 marks sum. Right on. If the tangent at any point if the tangent if the tangent at any point on the curve if the tangent at any point on the curve x power 2 by 3 plus y power 2 by 3 x power 2 by 3 plus y power 2 by 3 is equal to a power 2 by 3 intersects the coordinate axis intersects the coordinate axis at in A and B in A and B. Then show that length of AB is constant. So take a screenshot for that. It will save our time. If the tangent at any point on the curve x power 2 by 3 plus y power 2 by 3 is equal to a power 2 by 3 intersects the coordinate axis in A and B, then show that length of AB is constant. Now, beginning with the solution, now look here. Now look here, any point on the curve x power 2 by 3 plus y power 2 by 3 is equal to a power 2 by 3 is in the form right. Now look here, any point on the curve x power 2 by 3 plus y power 2 by 3 a power 2 by 3 is in the form a cos cube theta comma a sin cube theta, a cos cube theta comma a sin cube theta. So if you check this one, it will satisfy the result. Here you can say a cos cube theta power 2 by 3, right, and a sin cube theta power 2 by 3. So from this you can say a power 2 by 3, a power 2 by 3, and here cube and cube will get cancelled, so it is cos square theta, correct. And similarly here a power 2 by 3 sin square theta, a power 2 by 3 sin square theta. So from this a power 2 by 3 is common, cos square plus sin square is 1. So cos square theta plus sin square theta. So it is a power 2 by 3 into 1 and a power 2 by 3. So it's clearly satisfies this equation. So no need to write this one. Simply you can erase this one. Now any point on this and moving to the sum. So take like this, x is equal to a cos cube theta, correct. Now differentiating on both sides with respect to x, differentiating on both sides with respect to theta. Now differentiating on both sides with respect to theta. Here dx by d theta, a is constant. Here x power n derivative n into x power n minus 1. So it is 3 cos square theta, and after that here cos theta derivative minus sin theta, and it is minus sin theta, right, and it is minus 3a sin theta and cos square theta. Take y is equal to a sin cube theta, y is equal to a sin cube theta, right. From this differentiating on both sides with respect to theta, dy by d theta is equal to a into x power n derivative n into x power n minus 1. So it is 3 sin square theta, correct. And after that derivative of sin theta is cos theta. So it is cos theta. Now it is 3a sin square theta cos theta, 3a sin square theta and cos theta, right. And after that you have to calculate dy by dx. dy by dx is equal to dy by d theta by dx by d theta. So it is 3a sin square theta cos theta. So it is 3a sin square theta cos theta by denominator dx by d theta. Here dx by d theta minus 3a sin theta cos square theta minus 3a sin theta cos square theta. Now from this 3a cancelled, sin cancelled, cos, and it is minus tan theta, minus tan theta. Now you have to calculate equation of tangent. So like this, equation of tangent passing through equation of tangent passing through a cos cube theta, a cos cube theta, comma a sin cube theta with slope minus tan theta, with slope minus tan theta is y minus y1 is equal to m into x minus x1. Apply the result. Y minus y1 is equal to m into x minus x1. From this it is y minus a sin cube theta is equal to m is minus tan theta, so it is minus tan theta into x minus a cos cube theta. Correct? From this, tan means sin by cos. Y minus a sin cube theta is equal to minus sin theta by cos theta. Correct? Into x minus a cos cube theta. Right? From this cross multiplication, cos theta into y, cos theta into y minus a sin cube theta into cos theta is equal to minus sin theta into x minus sin theta into x plus a sin theta, and it is cos cube theta. From this is towards left hand side, sin theta into x, next cos theta into y. Now it is towards right hand side, a sin cube theta into cos theta, next a sin theta into cos cube theta. Correct? From these two, a sin theta cos theta is common. So from this, sin theta into x, sin theta into x plus cos theta into y is equal to a sin theta cos theta is common. So which is a sin theta cos theta is common, and after that ikkada sin square theta plus cos square theta. Now sin square theta plus cos square theta is 1. Here you can write 1. So it is sin theta into x plus cos theta into y, and it is equal to a sin theta cos theta into 1. Right? So dividing this entire equation with this term, what will happen? Sin theta into x by a sin theta cos theta. Correct? Next, cos theta into y, cos theta into y by a sin theta cos theta is equal to a sin theta cos theta by denominator a sin theta cos theta. Right? So from this you can say this is x by a cos theta. Next, here it is now after that it is y by a sin theta, right, and it is 1. So this is intercept form of a straight line. Now you are converting that tangent equation into intercept form of a straight line. So this is x-intercept and this is y-intercept. So you can say it is equation 1. 1 meets x-axis at, see, any point on x-axis means its y-coordinate 0. You can write like this: capital A cos theta comma 0, capital A cos theta comma 0, and capital B 0 comma A sin theta. Y-axis at, you can write like this: at B 0 comma A sin theta, right? And now moving to next slide. Here it is capital A cos theta comma 0, and capital B 0 comma A sin theta, correct? And after that you have to calculate length of AB is constant. How? AB distance you have to calculate full square root. Here x2 minus x1 whole square, correct? And y2 minus y1 whole square. Now it is full square root x2 minus x1 whole square, 0 minus A cos theta whole square, correct? And A sin theta minus 0 whole square, right? From this, here it is minus A cos theta, minus A cos theta whole square, and it is A sin theta whole square, correct? From this it is A square cos square theta plus A square sin square theta, correct? So from this it is A square into sin square plus cos square. Sin square plus cos square is 1. So it is full square root A square into 1, and it is A. So you have to prove that length of AB is constant. From this you can say length of AB is constant. Students, I think it is better to take a screenshot for this so that it will save our time. Any problem, students? So can you take the screenshot for this?
Yes, sir.
Okay, right.
Sir, can you go to the before slide?
Definitely. Moving to that previous slide. So you can take screenshot one by one. So this is beginning of the solution. Right down?
Sir,
You want question?
no, sir. Sir, could you explain it again briefly, sir?
Definitely. See, this is curve equation. On that curve, you have to take a point which satisfies the curve. So this point satisfies this curve. Simply, if you substitute A cos cube theta in this and A sin cube theta in this, then it will satisfy as A power 2 by 3. So any point on the curve is in the form like this. Now it is x coordinate and it is y coordinate. Now you have to take differentiation with respect to theta because parameter is theta here. So first calculate dx by d theta, right? And after that here y is equal to a sin cube theta. Then calculate dy by d theta. And after that calculate dy by dx. dy by dx means dy by d theta by dx by d theta. Here it is minus tan theta. And after that, calculate equation of the tangent with the help of point and slope. So point and slope means y minus y1 is equal to m into x minus x1. So after all continuation and simplification, you will get the tangent equation in intercept form. This is called intercept form of a straight line. From this, the straight line meets x-axis at this point, y-axis at this point. Right? Now, you have to prove that length of AB is constant. How? Take the distance between these 2 points, right? And the distance is small a, so it is completed. So it is better to take a screenshot for this so that you can listen more and more number of sums. So take a screenshot for this. Ready? So I am moving to next slide. So take the screenshot for this. And third slide. Once again, take the screenshot for this. Correct? And moving to last one. Again, so take the screenshot for this.
Done, sir.
Done, good. And finally, this one. So that it will save our valuable time. After that, you can write it in your home.
Done, sir.
Done. So this is our last one. So completed. And now last question, another important sum and another all-time favorite important sum. Ready? Moving to question number 7. Now, if the tangent at any point on the curve at any point P on the curve x power m into y power n, x power m into y power n is equal to a power m plus n, where mn not equal to 0, mn not equal to 0 meets the coordinate axis in A and B Then show that AP is to PB is a constant. AP is to PB is a constant. Right. So this is last one in this exercise and another all-time favorite important sum. Ready? Once again, if the tangent at any point P on the curve meets the coordinate axis in A and B. So similar model but slight variation. Ready? Now, solution. Look here. Let P x1 comma y1 be any point on the curve x power m into y power n a power m plus n. X power m into y power n is equal to a power m plus n. So once again, for this what to do? Logarithms you have to apply. So look here children, x power m into y power n is equal to a power m plus n. Correct? Now taking logarithms on both sides, from this logarithm of x power m into y power n, logarithm of a power m plus n. Now here logarithm of mn, logarithm of m plus logarithm of n. So which is logarithm of x power m plus logarithm of y power n. Here this one will come front and it is m plus n into log a. I will write down the students, I will write down the formula here with different color. See here, logarithm of mn to the base a, and it is logarithm of m to the base a plus logarithm of n to the base a. Logarithm of mn, logarithm of m plus logarithm of n. Here the formula applied, logarithm of a power m is equal to m log a. So these are the two formula we are applying here. Again m will come front. So the result is m log x. Here it is m log x plus n log y is equal to m plus n into log a. Once again see, logarithm of a power m, formula m log a. Similarly logarithm of x power m and m log x, logarithm of y power n, it is n log y. Now moving to next slide here, differentiating on both sides, differentiating on both sides. With respect to x, look here, m is constant. You all know that one. Log x derivative is 1 by x. Here m into 1 by x, m into 1 by x. Correct? Moving to previous slide. n into log x derivative is 1 by x. Log y derivative 1 by y. 1 by y. And y into dy by dx. dy by dx. Y, see, look here children. Y with respect to x is dy by dx. And after that, if you look at right hand side, it is m plus n log a. This entire thing is the constant. Derivative of constant. Yes, look here. Once again. See, m plus n into log a. That entire thing is constant. Derivative of constant is 0. So from this it is 0. Now look here, it is m by x plus n by y into dy by dx. Yes, once again maintain perfect silence. Right. From this m by x is shifted minus m by x n by y into dy by dx, and it is minus m by x. Correct? And this is shifted to right hand side. dy by dx is equal to minus my by nx minus my by nx. Now you have to calculate slope of the tangent at the point p x1 y1. M is equal to dy by dx at the point p x1 y1, because you have taken that let p x1 y1 be any point on the curve. Ready? So the result is minus m y1. The result is n x1. Correct? Now students, with the help of this point and this slope, calculate equation of tangent. Now equation of tangent passing through p x1 y1 with slope minus my1 by nx1 minus my1 by nx1. Correct? Correct. Now from this, how to calculate this one? So which is y minus y1 is equal to m into x minus x1, and after that y minus y1 is equal to m minus my1 by nx1 minus my1 by nx1 into x minus x1, and after that going for cross multiplication, n x1 into y minus y1 is equal to, going for cross multiplication, minus my1 into x minus x1. Correct? So from this you can say n x1y minus n x1y1 is equal to minus m y1x plus m x1y1. Correct? And after this, this is plus and this is minus. Now, so from this m y1 x m y1 x plus here n x1 y n x1 y is equal to right hand side it is n x1 y1 and m x1 y1. So it is m x1 y1 correct and n x1 y1. Now it is m y1 x correct plus n x1 y is equal to from these two m plus n into x1 y1 m plus n into x1 y1. Now from this is shifted towards left hand side. So m y1 by m plus n into x1 y1 into x correct. Here n x1 by m plus n into x1 y1 into y is equal to m plus n into x1 y1 by m plus n into x1 y1. So from this y1 cancel, this is come down x by m plus n into x1 by m correct. Now here x1 cancelled, y by m plus n into y1 by n and it is 1. So write down. And after that, so okay, no need. Moving to next one. See, that is the tangent meets x-axis at A and y-axis at B. Ready? Here at A m plus n into x1 by m and y-axis at B 0 comma m plus n into y1 by n. Now to take a straight line like this, right? So it is point A here, A, and it is m plus n by m correct into x1 comma 0. This is point A and here it is point B. B value 0 comma m plus n correct by n into y1. Right. And after that P you have taken as x1 y1 in the middle. Right. So it is AP is to PB. What is the ratio? x1 minus x is to x minus x2. So once again students, P divides AB in the ratio x1 minus x is to x minus x2. This formula you have learned in the earlier stage in the month of June, July in Maths 1B prerequisites. Beginning before locus, right? You will learn this formula. x1 minus x is to x minus x2. x1 means this thing. m plus n by m into x1 x1 minus what is x? X value is x1 is to what is x? X value is x1. Next, what is x2? X2 is 0. Right. And now AP is to PB is equal to mx1 plus nx1 mx1 plus nx1 correct by m minus x1 is to x1 correct, and after that it is x1 mx1 plus nx1 here minus mx1 by m is to x1. So it is cancel of these two. Nx1 by m is to x1 multiplying with m on both sides. So it is nx1 is to mx1, or you can write like this nx1 by mx1 and it is n is to m. So what we have to prove? See, then show that AP by PB is constant because n by m you can write it as n by m, right? N is to m or n by m both represents the same thing. Now n by m means these two like this, just like 4 by 6 or 5 by 10 like this. It represents a constant. It represents a constant. Over. Now, so once again take a screenshot for this. Right. So this is the question. So take a screenshot for this. Completed. Now moving to next slide. So take another screenshot for this. So it will save our time. Now take a screenshot for this third page. Next, fourth one. Next, fifth one. And now last one. Right. So one more page is also there. Correct. This is last one. n is to m constant. So take screenshots for this. So now these two are given intermediate more than 7 or 8 times. Ready? And after that, moving to next exercise, and for this now, yes, so just little over 10 minutes more you can learn the theory. So what is the theory involved in this? Angle between two curves. Angle between two curves. Ready? Angle between two curves is defined as angle between two curves is defined as angle between the two tangents angle between the two tangents at the point of intersection. At the point of intersection. Right. And after this, moving to next slide. See, angle between two tangents means, so already you have calculated how to calculate equation of tangent, right? Y minus y1 is equal to m into x minus x1. So, and the formula you have to apply here is tan theta is equal to modulus of m1 minus m2 by 1 plus m1 m2. Tan theta is equal to modulus of m1 minus m2 by 1 plus m1 m2. Right? So this is the formula for angle between two curves. Now take second point in that. If m1 is equal to m2, if m1 is equal to m2, then the two curves touch each other. Then the two curves touch each other. Now, third one, if m1 m2 is equal to minus 1, then the two curves cut each other orthogonally. right? So once we enter into the sums, you can learn the difference. When you will get m1 m2 is equal to -1, when you will get touch each other condition, when you have to find angle between the two tangents. Based upon this concept, if the question asked in intermediate, that may comes under 7 mark sum. Right.
Sir, orthogonally means what, sir?
Orthogonally means angle between, see, look here. m1 m2 is equal to -1 means the two tangents are perpendicular. Then the word is orthogonal. Curves cut each other orthogonally and the tangents are perpendicular. You are Shilpita? Yes, name of the student. Yes. See, m1 m2 is equal to -1 means the two tangents are perpendicular. And if you take the two curves like this, then the two curves cut each other orthogonally. If this condition satisfies, then name of the word is orthogonally. Right? If this condition satisfies, then the two curves touch each other like this. Right? It is intersection and it is touch each other. That is the meaning. Right? Now take a screenshot for this.
So, but m1 m2 is equal to -1 is only applied for when they are perpendicular. Not
Yes, when they are perpendicular only. He will give a sum like that. Prove that the two curves cut each other orthogonally. Then you have to prove that m1 m2 is equal to -1.
so then that means orthogonal means they are. Then we should prove they are perpendicular.
Yes, correct. The two tangents are perpendicular. Correct. Yes, name of the student?
Aditya.
Aditya.
Sir,
Ah,
sir, question.
question? Yes. Ready. Exercise number 10D. So take a screenshot for this. So take another screenshot for this. And ready. So the time is approaching 3:15. Okay, I will solve one problem. Exercise 10D. Write down. Find the angle between the two curves. Write down. Find the angle between the curves x plus y plus 2 0 and x square plus y square zero. Now, how to apply the sum for this? Ready? Find the angle between the curves. First, you have to calculate point of intersection of the two curves. Ready? Okay, we will do. Right. Look here. X square plus y square minus 10y is equal to 0 and it is curve 1, right? And here x plus y plus 2 is equal to 0. It is curve 2. So solving 1 and 2. So y is equal to minus of x plus 2. Y is equal to minus of x plus 2. In place of y, minus of x plus 2 here. So it is minus of x plus 2 whole square. Next, minus 10 into minus of x plus 2 is equal to 0. And after that, x square plus minus square is plus, and it is x plus 2 whole square, correct? And minus into minus plus, plus 10 into x plus 2 is equal to 0, right? So from this it is x square plus x square plus 4x plus 4, correct, plus 10x plus 20, 0. And after that 2x square plus 14x plus 24, 0. Now x square plus 7x plus 12 is equal to 0. So factorize for this. X square plus 4x plus 3x plus 12 is equal to 0. X into x plus 4 plus 3 into x plus 4 is equal to 0. And after that, x plus 4 into x plus 3 is equal to 0. X plus 4 is equal to 0. X plus 3 is equal to 0. X is equal to minus 4 or x is equal to minus 3. Now, moving to previous slide, y is equal to minus of x plus 2. Here, y is equal to minus of x plus 2 at x is equal to minus 4 or at x is equal to minus 3, right? Y is equal to minus of 3 plus 2, and it is minus of minus 1, and it is 1, right? So minus 3 plus 2 is minus 1, minus of minus 1 plus 1, correct? At x is equal to minus 4, then y is equal to minus of x is minus 4, minus 4 plus 2, correct? Minus 4 plus 2 is minus 2, right? And it is plus 2, right? So what are the points of intersection? Minus 3 comma 1 and minus 4 comma 2 are the points of intersection. Okay students, the time is not sufficient for this. Once again I will explain this sum tomorrow right from the beginning. Ready? Right. So today we are closing the meeting. The time is approaching towards 3:20. So thank you very much.
Thank you, sir.
Right.
Thank you, sir.
Right. Okay, fine.